All right, so this is video one of I think 3 for this week. We're going to go into the next module, which is variation. So we just finished up the module on measures of center, and I hope that you got a chance to work through all those problems there. One of the videos this week will be of me working through some of those problems that were assigned from the book that's uploaded in Canvas. If you didn't get to them, it's okay. You need to go back to them and make sure you've got them, because what I'm going to do is have a test at the end of this particular module on measures of variation and measures of center before we move into some other maybe trigonometric properties or a binomial discrete distribution. So here we go. So tonight I'm only talking about a few things, talking about range, variance and standard deviation of a population, and that's going to be it. It's going to be quite an overview with this. So let's get started right now. Let me double check what I've got. I've got my calculator, got my presentation, and my note sets. This note set right here is uploaded into the Moodle. Should be available to you now. There will be a vocabulary quiz during this section, just like there was in the previous section. I'll allow the use of notes for it. I want you to be familiar with these. That's my goal. Let's go over here. All right, so let's get started with range. So range is basically just the difference between the top number and the bottom number. Let me play this so it's maximized here. There we go. So range is the distance between the top number and the bottom number. So if a teacher had a set of test scores and somebody asked that particular teacher, said, you know, what was the range of your scores today? Well, if she had a student that got a 51 and that was the lowest, and a student that got 100 and that was the highest, then the range would be that 100 subtract the 51. So when you're looking at it, you're just looking at the highest number of the set and the lowest number of the set. Now, the benefit of a range is that it's very easy to compute. The drawback of a range is that it doesn't tell you a whole lot. If you had somebody get 100 on the test and somebody get a 0 on the test, then the range of that test is 100, the entire span of possible scores. So if you tell somebody the range of a test that had a 0 as the lowest and 100 as the highest was 100, that doesn't tell them a whole lot other than at least somebody got 100 and somebody got a 0. And same thing if somebody got a 5 and a 95. You've got a range of 90. It just means that somebody scored high, somebody scored low. That's all. So gives you a good general overview, but it's not the best measure of variation to use. Now, variance and variation, that just measures how much variance there is between the data. Before we go into this particular, into an example of range. So it talks about how varied the data is. So if you've got data that's all clumped together, for example, and I'll just overwrite this, see if it'll come up. For example, let's say that your test scores are 50, 49, 47, 51, maybe 55, and maybe 40. Let's just say those are your test scores. Well, there's not much variance between those test scores. If you look at the highest score here, if we were looking at range, for instance, and I looked at the highest score here and I said, well, I got a 55, and I subtract out the lowest one, which is a 40, then my range is 15. There's not a whole lot of variance between those numbers. Whereas the verbal example I gave a second ago, where a student got 100 and a student got a 0 and a bunch of scores in between, there is a lot of variance between that upper echelon score and the lower echelon. So here the range is 15 in a very simple example, but the variance of my data, it's all clumped together, so there's not a whole lot of variance. So let me look at another, as I'm just talking off the cuff here on this particular slide. But let's say that you have 100, 70, and I'll just stay with test scores, 60, 50, 60, 42, 95, 31, maybe a 12, 25, 13, and a 92. Let's say that those are your test scores. Well, as a teacher, I wouldn't be very happy with that, I can tell you that. However, there's a lot of variance between these numbers. When you find the mean of this, like we did in the previous module, and you compare the mean to each one of these actual numbers, you're finding the deviation from the mean of these numbers. You're looking at the variance of that individual number to the mean. And then as we push forward a little bit into to variance and standard deviation in this particular module. We're looking at it on average across the entire set of numbers. So in this case, there would be quite a bit of variance, with that being what looks like your lowest, that being your highest. So your range is going to be what? 100 minus 13 is 87. So range would be, range would be 87. Quite a bit of variance in between this number set, between these numbers. All right, let me clear this and come out of this. All right. Let's take a look at an example. A little bit of context here, but nothing major. A corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries. So the starting salaries in thousands of dollars. So you got 41,000, 38,000, all the way up, not up to, but to the end at the far right, 42,000. These are not in order. So if I needed to find the range of this, this is not a very difficult. There's a couple more slides that I'm going to negate because I don't think it's needed to find in order to teach a couple of examples on range. So all I need to do with this is find the highest number in the set, find the lowest number in the set, take the difference, that's your range. So the highest number is at 41, 45 is higher, 47 is higher, whoops. So 47, so there's my highest number. And my lowest number is like 37. Okay, that makes it very simple. Let me do a little bit darker here. So I've got 47, subtract 37. So my range is 10. And if you look at that range, I mean, this is a measure of variation. And I said earlier that it has some drawbacks, but it also has some benefits. If you look at the numbers themselves, 41, 38, 39, 45, they're all clumped together. There's not a whole lot of variance between those numbers. And then when you look at the resulting range for this, the range is 10, which tells you there's not a lot of variance between those. Now, that's where it ends. It tells you there's not a lot of variance, but you really can't infer much more from the data set. However, that 10 tells you, it paints a picture of the measure of variation of this. So far we've jumped in and we've talked about range just a little bit, actually a lot, but you take the upper number, subtract the lower number, that gives you the range, and the range is a very crude way to measure your variation. All right, let me erase all the strokes there. Let me get out of here. All right. Yay, look at that. I just did that without having a slide. So you find the range of this set, very easy. So if you have a, I just noticed that my scrolling ticker says measures of centers. Apologies, that should be measures of variation. So if you have a problem on a test that says find the range of this data set, that is a gimme problem. You want to give me more of those because it's really very easy to compute. And as far as the understanding of it is a measure of variation, and it gives you a crude interpretation of how close together or how far apart the numbers are, which is variance. All right. Deviation. So I talked about this just a second ago. And first of all, let's take a step back. There's a couple of things that I want to look at here. So the deviation, the difference between the data entry and the mean of the data set. So you have to find the mean first. So I want to backtrack for just a second. I'm not going to make this a long video, but I do want to make sure if I have a way to scaffold in here, I'm going to. So what we did in the previous section was find the mean. Now that is the mean for a population, which is Greek letter mu. X bar represents the sample mean. So if you're working with, and this should be a bar right there too. It didn't carry over very well into Keynote. In order to find the mean, you add up all the X values and you divide by how many there are. You do the same thing for a sample mean and you divide by how many there are. Sample mean, the number of entries in the set is represented by a lowercase n. In a population is represented by an uppercase n. That just indicates what you're working with. Both of these are worked the same way. So you have to be able to find the mean in these sets. All right. Oops. Let me pull that off. I'm going to leave that bar over the x because that's what it should be. So basically what you're doing is you are, number one, finding the mean. A skill that we've already worked with. We may not have mastered. You may not have mastered it yet, but that is something that you need to know how to do. So you find the mean of the set. Number two, you find the deviations. Now, what are the deviations? What does that mean? The deviations just represents how much distance is between the mean and the actual value. So you find the mean of the entire set. That's a measure of center for the entire set. Now, how far is each individual data point from the mean? That's what the deviations are. The only difference in these two right here is one is working with a sample, and the other is working with a population. I'm gonna try to stay away from sample tonight. I'm gonna stick just with population just to keep it consistent from here on out when I describe things. So find the mean, find the deviations, and then we're gonna take that a step further as we go into the calculation of variance itself. Because if you remember, at least verbally what I talked about was we're going to talk about range, variance, and standard deviation. So we're talking, I did mean to do that. Let me see if I can go forward. Actually, I want to go backwards. There we go. I want to go back to here. Okay. So in this particular set, the one I worked just a second ago, in finding the range was 10. No problem. I'm not concerned with the range. I'm pushing forward now into the deviations because I'm going to use those deviations, square those for what's called a sum of squares, and use that in a formula to find the variance of this particular set. So again, I'm going to stick with this set for tonight and try to work with it. I will push a little bit into another one, but I do want to keep this shorter than normal. So what is the mean of this set? Well, I need to find the mean. I'm going to assume it's a population. That's a very small population, but I'm just going to work with this formula. Summation of x divided by, it's big N. So basically I've got 41 plus 38 plus 39 plus ... which represents all the numbers in between, plus 42. So I'm just going left to right. Now don't let those dots confuse you. I may have mentioned that in the previous video. That just I'm going to run out of room, so that just represents the numbers in between. I'm going to add all those up. I'm going to divide by 1, 2, 3, 4, 5, 6 by 10. Okay? No problem. So let me put into the calculator my numbers. And I need this, I would show you what I'm doing in the calculator, except that I need this up so I can see the numbers. $41, $38, $39, $45, $47, $41, $44, $41, $37, $42. Okay, there it is. So I get 415 divided by 10 equals 41.5. So I found the mean. Okay, no problem. I'm going to write the mean up here at the top, and then I'm going to erase off what I laid out as my working form. Let's go dark green for this. So my mean, which is Greek letter mu representing population mean, is equal to 41.5. And I'm putting it up there as a reference because I'm going to take all of this off. Yeah. Okay. Deviations, remember, are how far away from the mean, the measure of center, each number is. So the deviation here would be, if I'm looking at this first number, it would be 41. subtract 41.5. Okay, minus 0.5. If I'm looking at the second one, 38 subtract 41.5 equals, I don't know, 38 subtract 41 be 3. What is that, minus 2.5? Is that right? And I could put these in the cells of the calculator. And again, I apologize that I don't have the calculator right up here, but I need to see the numbers while I'm working with them. Minus 3.5. It's a little bit late. Numbers can get skewed. Then we just follow that pattern all the way down to find the deviations. These numbers right here, that negative 0.5 and the negative 3.5, represent the deviation of the particular value, in this case 41 for the first one, which is negative 0.5 away from the mean, and the deviation from the 38, which is negative 3.5 away in terms of the deviation. Now, if you took a sum of all these deviations, you would get 0. So the distance from the mean to all the different points, if you laid that out, the sum would be 0. But we're going to do something special with it to keep it from becoming 0 within our variance, because we do want to know how far each one of these is from the mean, but we're going to have to square it so that we don't have some kind of 0 in a numerator that makes everything 0 every time. That would make no sense. So let me introduce to you how we're going to use this deviation. So, and I am sticking with my theme of working with population. So I'm jumping from range into deviation, which I just covered, and now into the form that we're going to use, which includes those deviations, each individual deviation, to find the variance of this set. So we found the range, yay, check. We found that earlier, it was 10. We found the mean, it was 41.5. And now we're going to find the variance of this set. So I'm going to kind of walk you through it here. I think I'll use green this time. Population variance is represented by lowercase sigma squared. Now, one thing about statistical concepts, and I'm trying to get in the course of this, in this particular Math 4, I'm trying to get you ready for some concepts that you're going to see in early college courses. All the way up to normal curves. We'll do a bit of normal curves so you've got a feeling for that. And then we'll have trigonometric properties, logarithms, exponentials, things like that near the end. But right now, the part that we're working with is statistics. One thing that throws students off in statistics are these classifications. This lowercase sigma squared, people just can't keep up with it. So my recommendation is, as you work through problems, as you get familiar with these formulas, I would write the form every time. Write the formula every time, and you have the note sheet. All of these will be on the note sheet for you within each module in Canvas. And I would write the form, then I would substitute in, and I would work through it in that manner. The population variance is found by taking the sum of the deviations, which, remember a second ago I told you that gives you 0, but we're going to square those. And then in the bottom, we're just going to divide by how many there are in the set. So how that looks is, I'm definitely going to run out of room, so I'm just going to put a couple of examples up here. And there were 1, 2, 3, 4, 5, 6, 7. Thought there were 10, so n equals 10. I probably should write that up here as a reference. And then the summation of these is going to look like this. So it's the summation of deviations squared. So that's the sum of squares. So we have 41 subtract 41.5, and then we're going to square it. So that negative 0.5 is going to be squared, plus 38 minus 41.5 squared, plus, and I'm just going to go right below it, dot, 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 plus, and I'll go all the way to the end, 42 subtract 41.5 squared. Now that looks messy because I went underneath, but remember this is all in the numerator by the form. And when I say remember, I mean remember from 45 seconds ago. It's going to be divided by 10. So I find my deviation, square it, find my deviation, square it, find my deviation, square it, then I take the sum of all those, divide by 10, that gives me my variance. A little bit messy. A little bit messy. Mainly messy for me just because I run out of room on the iPad up here. Okay. So I've introduced range. I've walked through range through an example. I think that's enough for range for the time being. I've walked through deviation, looking at the deviation from the mean of each data point in the set. And then I talked about we have to square those deviations because if you take the sum of all the deviations in the set, then you get 0. We can't use 0 in this form, so we have to square that so we can work with it. All right. We did this one through the deviation. We found that, no problem. Okay, here's a pretty good graphic, so I'm going to leave this up here for just a second. So this is what I started working below as I was talking through it. So this is the same set we were just working with that we found range with. 41 subtract 41.5 equals negative 0.5. 38 minus 41.5, negative 3.5, and so on and so forth. And note down here at the bottom, and let me just throw out a couple of things here. I've talked about, both in the first module and tonight, that mean for the population is represented by Greek letter mu. The variance is represented by lowercase sigma squared. Let's put another 2, so sigma squared. And that uppercase sigma represents summation. So mu, sigma squared, and uppercase sigma. Those are very important to know. I can't emphasize that enough. You have to know these, and when you see them, you have to recognize them. These all deal, with the exception of summation, which applies anywhere. The mu and the lowercase sigma square work with populations. Okay. So working through some computations on this tonight. So let's look right here. The sum of these values was 415. We needed that to find the mean. But when we're looking at the sum of the deviations, note that it does exactly what I said it would. It becomes 0. So that negative 0.5 plus negative 3.5 all the way down to the 0.5 at the bottom all add together to be 0. I like this graphic. I'm going to come back to the calculator. I may do a 4th video later in the week and talk about calculator use with the cells, the TI-84, which you may not have used a whole lot in your courses because you're probably using Desmos for the tested courses and things like most high schools do. Here's what I wrote out a second ago, and this is probably where I will draw it to a close tonight for an opening video. So the form for a population variance is that summation of the deviations squared of a set divided by how many terms are in that set, which is n. Whoops. I apologize for that. Okay. So, and again, I am working with population, and we are working with variance and standard deviation as we work through measures of variance. And the problems that we work with will be determining what the variance is, population variance and sample, and then the population standard deviation and the sample standard deviation. Okay. What I will end with this is just that you have to be familiar with these formulas. Again, I would suggest that once I assign the problems and you start working through them, that you write the formula first, fill in the pieces of the formula, and then work it out computationally. I think that helps solidify it, at least for the semester, the formulas that you're working with, so that you can at least work with them. And then later on in life, you may not remember the formulas, but you'll have some semblance of how to work with them if you ever took another stats course. So the last thing I wanted to talk about between variance and standard deviation is that there is a mathematical relationship between variance and standard deviation. So notice here that this is the exact same formula as here. So in order to find the standard deviation, all you have to do is take whatever you find for the variance and take the square root of it. You just take the square root of the variance, you find the standard deviation. That's very important. Now, if you're given the standard deviation and you need the variance, then you just square it and you get back to the variance. So there is a mathematical relationship between these two. All right. I am trying to keep these videos down a little bit. I've got two more that I definitely want to put out this week with this module. One is going to be looking back at the problems both from this new set. I want to look at the new set problems, a couple of them, and I want to look at the old set problems that you worked through the last module with measures of center, which is in my ticker at the top, which I should have changed that and I didn't. So let me roll out of this and get over to here. And by the way, I think I mentioned this before, but if you don't have a TI-84 calculator, please borrow one from the school. If you have a hard time getting one, reach out to me and let me know. Be glad to get you one that you can use at least for the duration of this course. We are going to be using this starting this week, actually. We'll be doing a lot more in it. This note set, the Measures of Variation, is a note set that I put together years ago. I basically just share it with my students. You need to be familiar with all these terms. I talked through a good piece of this tonight. I talked about range, variance, standard deviation. Variance of a sample, I did not. Variance of a population, I did. Sigma, sample standard. So pretty much all of this first page here I talked through. You've got empirical rule down here at the bottom with normal curves. Ignore that for the time being. We are working with variance and standard deviation. I will stay on that until I feel like we have mastered that before I move on into empirical rule, which in my opinion belongs more in measures of position. But that's just me. Okay, that's where I'm going to end the video. Thanks for watching. If you have any questions, as always, reach out to my email address or reach out through Canvas, and I'll be glad to get back with you to let you know where we're going, what you need to be doing, and if you need any help with stuff, I'll be glad to help you at any time. All right. Let me get my scroll over here. All right, thank you.